Hello everyone, welcome to my channel. Today we are going to discuss about the indefinite integration. This topic comes in 11th as well as this 12th standard for commerce as well as the science arts students. This topic is very deeply explained in the standard 12th. Okay, so here we will be dealing with this topics in this chapter. Like the first topic that we are going to do is the introduction to integration. Second topic will be basic integration formula, and the third would be methods of integration. For this video we are going to discuss the three topics. Now also we'll understand like how we come across the integration, why do we need to do the integration. Okay, so I'll take you to the introduction part where I'll explain you some basic concept of the integration, like how it is introduced to the mathematics. So let's just look at the first introduction part, that is the differential calculus is centered on the concept of derivative. The original motivation for the derivative was the problem of defining the tangent lines to the graph of functions and calculating the slope of such lines. Okay, so here basically why do we need to do the derivatives of the function? The motive was very simple. We used to have defining tangent lines to the graph of the function, and we need to calculate the slope of such lines. But the another thing here is the integral calculus. Integral calculus is motivated by the problem of defining and calculating the area of the region which is bounded by the function. Now here why do we need to do the integration is clearly written that we need to define as well as to calculate the area of the region which is bounded by the respective function. Okay, like suppose we take an example here that you have a function f, okay, and it is differentiable in the interval I. Okay, so if it is differentiable in the interval of I, so f dash exists at every point of I. Okay, so here we know that the function that could possibly have given the function as a derivative are called as the antiderivative. Okay, so what are the antiderivatives? So antiderivatives are the function that could possibly have given the function as a derivative are known as the antiderivatives, or also we say as a primitive of the function. Furthermore, the formula that gives all these antiderivatives are known as the indefinite integral. So we are going to deal with the formula section in the later half. This process is known as the integration, we know that. Now there are many practical situations where we use the integration. Mostly it is used in the fields of engineering and many other technical fields. Okay, so that is why you need to have the clear vision of calculating the integration as well as the differentiation part. Okay, now what are the type of problem that we are going to deal in this? So there are two types of problem that will be there. So the problem of defining a function whenever its derivative is given. Okay, so the derivative will be given and you have to find the primitive function, or we can say antiderivative of that part. And the second part is the problem of finding the area bounded by the graph of a function under certain condition. So they will tell you to find the area under the or bounded by the function. Okay, like we have these two forms of integral. First is the indefinite and the second was is the definite. Together we constitute as a integral calculus. Okay, so in this video we are going to deal with indefinite integral. Okay, and in the upcoming videos we are going to study about the definite integral also. Okay, now first we need to understand the indefinite. Once you understand the indefinite, you will easily understand definite integral. Okay. Okay. So now we'll move on to the basic. We have done the introduction part, we understood about that part. Now we'll study about some basic formulas that we need to have in the calculus, okay, or in this integral calculus. Okay, now let's just study that how do we do the integration or how do we represent it. Okay, so suppose you have a function that you want to integrate, we say f of x. Let's say you have a f of x and you have to integrate it. So the operator that we use for the integration is like this, we draw this, and the variable that you have in your function we write with the dx part. Okay, so we read this as the integration of f of x with respect to x. Okay, I'll just write it down. We read this as integration of f of x with respect to x, with respect to variable x. Okay, so if the function contains x, that will be integrated, and other than x it will be treated as constant part. Okay. Okay, so let just we say that this is I. Okay, now let's see examples. Suppose you already know about the derivative, you know how to calculate the derivative. Okay, so suppose we take a derivative of sin x. Okay, just to understand more about the integration. So we are calculating the derivative of sin x. Now the derivative of sin x you already know, which is cos x. Okay. Okay, so this is the derivative of sin x, which is cos x. Now we'll do the reverse process. Okay, you have this cos x, okay, and you have to integrate it with respect to x. Okay, so this answer should be your sin x. Okay, and plus it will be c. Okay, now I'll tell you, since this is a derivative, we have calculated the derivative of sin x, which is cos x. So we can say that this is the derivative of sin x. Okay, now when we have calculated the integration of cos x, what we got is the sin x. Okay, which is the original function, or we can say the primitive, or also it is known as the antiderivative. Okay, antiderivative. Okay, and what is this c? This c is the arbitrary constant. Okay, arbitrary constant. We write this in indefinite integration. Whenever we do the integration, we use to write plus c along with the antiderivative answer. Okay, now what is this arbitrary constant? This arbitrary constant is a parameter. If you wear this, or if you keep wearing this, the answer of the integration can change. Okay, you can think in the reverse process. Okay, now let's just study about the integration formula. I have created a list for you. Okay, we'll go through it one by one. Okay, so the first here is the integration of a constant, any k, okay, with respect to the variable x, that will be x plus c. Now each and every answer you will see plus c over here. Okay, as I have already told you, you have to write plus c always. So the integration of any constant would be kx plus c. Next, integration of x to the power n. So you have variable x and you have a power of n, so that will be x to the power n plus 1 upon n plus 1. The same power would become in the denominator, plus c. Next, I have shown the example. So the integration of root x. Now root x, that means the power would be half. If you apply the above formula, that will be x to the power half plus 1 upon half plus 1. half plus 1 gives you 3 by 2 upon 3 by 2, and 3 by 2 comes up, that becomes 2 by 3 x to the power 3 by 2 plus c. So this would be the integration of root x. Okay. Next, 1 upon x, the integration of 1 upon x is log of mod x. Okay, just remember this is a small l, small log mod of x. Okay, you have to write in the terms of mod. Okay, since log does not accept negative values. Next is the integration of sin x, that we got as minus cos x plus c. Integration of cos x you get as sin x, integration of sec square x, that you get as tan x. Okay. Next part, integration of cosec square x gives you minus cot x, integration of sec x is log of, in terms of mod, sec x plus tan x, integration of cosec x dx, that will be again log in terms of mod cosec x minus cot x. Then we have the integration of tan x. Tan x is log of sec x, and integration of cot x, that will be log of sin x. Okay. Next we have the integration of sec x into tan x. Both are multiplied, so the value would be sec x plus c. Again the integration of cosec x into cot x, that will give you minus cosec x plus c. Okay. Next, the fifth one is the exponential formula, 15th one, the exponential formula, which is e raised to x. Integration of e raised to x will be e raised to x, and the last one is a raised to x, gives you the integration as a raised to x upon log a. Okay, now I'll ask one question. Okay, you have to find the integration of 1 upon root x. Okay, now you can do this by applying the same power formula that we have studied. I'll tell you. So how this will be x to the power half. Okay, when you take it in the numerator, it becomes negative half. Now when we talk about the power formula, it is x to the power n plus 1. We have the value of n is negative half, so that will be negative half plus 1 upon negative half plus 1 plus c. Okay, now negative half plus 1 is half, and this will also be half plus c. So this 2 will come upward, so that will be 2 root of x plus c. X to the power half is nothing but root x. So we got the value of integration of 1 upon root x is 2 root x plus c. Just remember this also, that will be point number 7. If you remember this, you can use this directly. Okay, there is no need to explain all this, since it has been understood. It works on the same principle of the power. Okay, yeah, so this was about the power, and we have calculated mostly the mostly used formulas. Okay, we are done with the formula part. Now we'll solve some of the example. Okay, the first theorem that I'll tell you, which is based on the subtraction as well as the addition of the two different functions. Okay, so suppose you have the two function f of x plus minus g of x. We are taking the two theorems in this only. So you have these two functions which is getting added or subtracted, and you have to integrate this. Okay, so what you can do, you can integrate it f of x dx separately, keeping the same sign. Okay, doing the same with g of x dx. Okay, so what happens here is you cannot calculate both the functions by adding or subtracting it. So what you can do, you can calculate the integration separately and while keeping the sign same. Okay, next theorem that we are going to do is the integration of the constant multiplied with f of x, that is the function. Okay, so in this case you can take your constant outside and you can do your integration part. Okay, what will be the answer? It will be getting multiplied with the k. Okay, so now in this video we are going to end with the 3 examples. We will be solving it, and let's just see the first example, which is I is equal to integration x to the power 3 plus 3 to the power x dx. Okay, so what we'll do, we'll give the integration sign to each one of the function here like this. Then since this function is x to the power n, right, so what we can do, following the same formula, n plus 1 upon n plus 1, so this will be 3 plus 1 upon 3 plus 1 plus this is 3 raised to x, which is same as integration of a raised to x. So if you remember, the formula of a raised to x is nothing but a raised to x upon log a plus c. So this will be, here the value of a is 3, so this will be 3 raised to x upon log 3 plus c. So we'll solve this. This will give you x to the power 4 upon 4 plus 3 raised to x upon log 3 plus c. Okay, I hope you understood this problem, which was quite simple, completely based on the formula. Okay, next question 2. Here we are going to find the integration of tan x plus cot x the whole to the power 2 dx. Now the problem here is, we have the formula of tan x, we have the formula of cot x, but here the problem is we have tan x plus cot x to the power 2, okay, the whole raised to power 2. So we have to deal with the power first and then we can integrate it separately. Okay, so we will find the formula, that is a plus b to the power 2 is nothing but a square plus 2ab plus b square. You must be aware with this formula. So here also this will be a square plus 2 into a into b. We have the value of a is tan x and b is cot x plus cot square x dx. Okay, then what we can do, keep the tan x as it is. We know that tan x and cot x are nothing but the reciprocals of each other. Okay, if you remember, tan x is nothing but 1 upon cot x. Okay, so if you take the cot x here, that will give you tan x into cot x, which is equal to 1. Okay, this is from the trigonometry part. So this will be 1 plus cot square x dx. Okay, we haven't integrated yet. Okay, we have just opened the power of 2. Okay, I hope you understood till here, right? Now the formula of tan square and cot square, we'll look for the formula of tan square and cot square. If you must remember, we don't have the formula of tan square and cot square, but instead we have the formula of sec square, okay, and we have the formula of cosec square. So what we can do, we can write the tan square in the terms of sec square, which is sec square x minus 1, okay, plus 2 plus this will be cosec square x minus 1, okay, dx. Now what we'll be doing, this is minus 1 and minus 1 gives you minus 2, okay, and we have the plus 2 over here. So overall we left with sec square x plus cosec square x dx. Okay, now we will integrate it separately, sec square x dx plus integration of cosec square x dx. Okay, so we know the formula of sec square x, which is nothing but tan x, and we know the formula of cosec square x, which is nothing but minus cot x plus c. So this was very simple. Okay, if you are having a question where the problem in which you can apply the formula directly, you can solve it, but other than that you have to find that terms which you have the formula, and then only you can integrate. Okay, I hope you understood this problem. Okay, next. So next here is third problem. Third problem here, it says I is equal to integration, we have in the numerator as 3 raised to x minus 4 raised to x the whole upon 5 raised to x dx. Now what we'll do here is we'll give this denominator to both of them, that will be 3 raised to x upon 5 raised to x minus 4 raised to x upon 5 raised to x. The power here in the numerator as well as the denominator is the same, so what we can do, we can write 3 upon 5 the whole to the power x minus 4 upon 5 the whole to the power x. We can do this, right? Now we'll integrate it separately, so just okay. Now if you can remember again, this is in the form of a raised to x. Okay, now in the first case the value of a is 3 by 5 and in the second case the value of a is 4 by 5, but our formula will remain the same, that is a raised to x upon log a plus c. So here it will be a raised to x, that is 3 upon 5 raised to x upon log a is here is 3 by 5 minus this will be 4 by 5 to the power x upon log 4 by 5 and this will be plus c. Okay, I hope you understood this. The whole motive to create this video was to make you understand about the basic introduction to the indefinite integration, as well as to explain you the meaning, and we have done some basic problems here. In my next coming video we will be solving some of the difficult problems that are coming for your exams. Okay, so till that stay tuned, subscribe to my channel, and thank you for watching this video.